Welcome to The Explainer. Today, we're diving into something pretty cool, a recipe for predicting the future. And no, we're not talking about crystal balls or any of that guesswork. This is a real step-by-step method. So let's jump right in. So, let me ask you, how do you actually predict the future? I mean, we all want to know what's coming next, right? Whether it's for sales, the weather, maybe even stock prices. But what if I told you the secret isn't about gazing into the future, but actually digging into the past? Yep, you heard that right. The secret isn't some kind of magic. It's a recipe. A reliable, repeatable recipe for finding all the clues that are hiding in plain sight, right there in our past data. And today, we're going to walk through it, step by step. Okay, so to really get our hands dirty, we need a challenge, right? A puzzle to solve. And boy, have we got a good one for you, straight from the golden age of air travel. All right, check this out. This is our puzzle. Monthly international airline passengers from 1949 all the way to 1960. And you can spot two things almost immediately. First, look at that clear upward trend. I mean, more and more people were flying every single year. But second, there's this rhythm, this repeating seasonal cycle. You see those spikes? That's probably summer holidays. So the big question, the real challenge, is this. Can we teach a machine to see both of those things at once, that long-term growth and the yearly rhythm? And the answer is a big yes. But not with the data as it is. We can't just throw the raw numbers at it. First, we need to give our data some superpowers. Honestly, this is where the real magic happens. And we do this with something called feature engineering. Now, that might sound super technical, but I promise it's not that scary. It's really just about using our own knowledge, our common sense, to create new, smarter inputs from the data we already have. Think of it this way. We're not just feeding the machine a bunch of numbers. We're giving it context. We're pointing and saying, hey, look over here. This is the important stuff. So here it is, our 3-step recipe for awesome features. Step 1, we create what are called lag features. This is kind of like giving the model a short-term memory. We're just telling it, hey, just so you know, this is what happened last month. It's a super simple but really powerful clue. Step 2, we create a rolling trend. For this, we use a 12-month average, and that helps the model see the big picture, that overall upward climb we saw. And finally, step 3, calendar effects. This is as simple as it sounds. We literally tell the model what month it is, January, February, whatever, so it can finally learn that yearly seasonal rhythm. And voila, here's what that looks like in practice. On the left, you've got the plain old original data, but on the right, that's where you see our new superpowered features in action. So now, for any given month, the model doesn't just see a number. It also knows what happened last month. That's our lag_1 column. It sees the 12-month trend in the roll_mean 12 column. And it knows exactly what time of year it is. We've basically turned a boring list of numbers into this really rich, context-aware data set. It's a total game changer. Okay, our data is now officially supercharged. So what's next? Well, now it's time to build our time machine, the predictive model that's actually going to do the forecasting. But wait a second. To really know if we've built something amazing, we need something to compare it against, right? So let's stage a little competition. In this corner, we have our challenger, the naive guess. This model is, well, it's pretty simple. It just guesses that next month is going to be exactly the same as last month. And in the other corner, our champion, the smart model. It's a random forest model that's going to use all of those awesome new features we just created. Let's see who wins. All right, the data's prepped, the models are ready to go. Let's get to the main event and see how this thing actually performs. It is time for the forecast face-off. First up, the naive guess. Now, we measure performance using a score called mean absolute error, or MAE for short. All you need to know is the lower the number, the better. And the naive guess gets an error score of 0.138. Okay, so that's our baseline. That is the number to beat. And now, the moment of truth. How did our smart model do with all those special features we built? Drum roll, please. It scored 0.057. Wow. That is less than half the error of the simple guess. That's not just a win, my friends. That is a total knockout, a huge victory for our feature engineering recipe. So what does a number like that actually mean in the real world? It means the model's forecast was just incredibly accurate. It didn't just get the big picture right, it nailed the little details. It predicted those seasonal summer spikes, and it perfectly tracked that steady, decade-long climb in air travel. Pretty amazing, right? Okay, that is an amazing result for the airline data for sure. But Was it just a fluke? A one-hit wonder? Or is this recipe something we can use for, well, for anything? Let's find out. Let's really put this recipe to the test now. We're going from the skies down to the farm. We're going to try to forecast monthly milk production. Now, this data also has a strong seasonal pattern, but it's a completely different world. So the question is, will our recipe still work? Well, the results really do speak for themselves. The simple, naive guess, it had an error score of 12.87. But our smart model, using the exact same three-step recipe we used for the airlines, crushed it again, with an error of just 7.42. This is huge. It confirms that our recipe isn't a one-trick pony. It's actually robust. So let's wrap this all up. What is this universal recipe for forecasting? It really boils down to 4 key steps. First, get your data ready. Clean it up. Second, and this is the absolute key, engineer your features. Give the model some memory with lags, a sense of the big picture with rolling trends, and an understanding of time with calendar effects. Third, train a smart model on all that new, enriched data. And finally, number 4, always test it against a simple baseline. That's how you prove that all your hard work actually paid off.
So there you have it. We've seen this recipe work for forecasting flights and for forecasting farming. It's an incredibly powerful tool for finding those hidden patterns in the past to help us predict the future. Which really just leaves one last question. A question for you. What would you forecast?